Antenna. Antenna is a vital communication device that is used at the transmitting end and also at the receiving end. Dipole antennas are only directional and it is only used at the transmitting end. For visual reference and familiarization, these are some pictures of log periodic dipole antenna. Actually, the most common type of antenna used in wireless communication technology is a log periodic dipole. What is then the goal of this antenna? It is simply to receive every frequency in that particular area. In order to reach this goal, the manufacturer must consider every factor that can affect the performance of the product. These are the factors to be considered to maximize the performance. The first one is the length of the boom. The second one is the length of the elements. Third one is the spacings of the elements. And the last one is the angles. But above all of this, upon reaching the necessary quality of the product, it is a must that still safety and health are the most prioritized.
I will be discussing about the process flow diagram of the production of log periodic dipole antenna. I'm your speaker, Michael Jesus. In the first part, we have the determination of dimensions. We have the inputs, frequency meter, and line gauge. In order to create a scaled length of boom and scaled length of elements, and to establish a bandwidth, we need these materials. So this is a sample figure of the proposed production of a log periodic antenna. To give you a brief discussion about it, the driven element in the antenna is electrically connected to the receiver or transmitter, whereas the boom supports and contains the driven elements. In the next step, we have the cable stripping. So, in order to strip the cables, we need a crimper or anything that cuts through the wires, and we will just leave the braided shield here or the copper because we need that to transmit electrical signals onto your antenna. So the outer sheeting acts as an active boom to collect the radio energy from the elements. So next we have the cable stripping. Example here is a man that is cable stripping the coax cable which is needed in order to create the boom. So he's cutting it using a cutter and with no protective equipment. So later on we will discuss the safety hazard of what he is doing. So to the next step, we have drilling a platform. So we need a platform, a steel platform, and a drill itself. So we can drill the steel platform in intervals and connect the driven elements there. But we have here an example of how they drill it in the industrial manufacturing processes. So they drill it by using a punch and shear mechanism, and it is more precise than measuring it by a line gauge and drilling it by your own. So all of here are created using a machine. So next step is connecting the elements onto the boom. So we have inputs of hammer, and we also have the element itself. You can use a copper or steel, anything that conducts electricity. So the output is, you can see here, the man is using a hammer to connect the elements onto the boom. The boom is the coax cable that is sheeted. The driven element or the active element in the antenna is typically a metal rod. Anything that is metal is possible. So the next step is sealing. we're going to seal the elements onto the steel platform and onto the boom itself. So what we have here are 4 dies, and the middle part would be your element. So to secure it properly, you'll be using the switching process. So the output would be in the figure like this. So we have the boom, which supports the driven elements and the reflector and the detector, and the driven element, which are typically in intervals onto the boom. So the detector and the reflector are both driven elements, just in different sizes. So using the line gauge, we can set to different sizes or centimeters depending on what is needed. On to the next part is we have testing. So the antenna measurement ensures that the antenna meets its specifications or simply to characterize it. So we have typical parameters, we have the gain, the radiation pattern like this, the bandwidth, the polarization, and the impedance. So these particular processors are used to test a antenna if it's working or not. Some manufacturers accept or reject their antenna depending if it meet the criteria or it meet the tolerance of their work. So if the antenna is within the tolerance or within the specification or characteristic of a working antenna, then we can box and wrap it using carton and a bubble wrap. So that's how you create an antenna, a simple antenna, a log periodic antenna. Thank you for listening.
I'm Paul Johansen, Pagala, and I am here to present about the process flow diagram table. This is the identification of occupational health and safety regulation of each hazard identified in the process flow diagram. In addition, the identification of the mitigating and preventive measure of each hazard will be done. For the first process, determination of the dimension of boom and elements, there are 2 hazards: risk of getting electrocuted if the cables in the measurement devices are shorted, and equipment malfunction or breakdown. For the first hazard, it is classified as a physical hazard. The regulations are electrical installation, personal protective equipment, and electrical safety inspection. It is needed to have a proper handling of materials and lighted workplace to be able to see if the wires are shorted. For the second hazard, it is classified as a safety hazard. Usage regulations are hand and arm protection, PPE, head protection, eye and face protection, construction and maintenance. It is needed to have proper checking and regular maintenance of the equipment. The second process is stripping of coaxial cable. The hazard is risk of getting cut. Classification is safety hazard. OSH regulations is R, hand and arm protection, welding or cutting, personal protective equipment, illumination. Preventive measures is use of gloves in order to avoid getting cuts. For the third process, cutting scaled aluminum block, it is the same hazard as the second process. It has the same classification, OSH regulations, and preventive measures. For the fourth process, drilling of aluminum boom, there are 3 hazards: risk of getting electrocuted if the cables are shorted, risk of inhaling metal fumes, and risk of getting cut due to the improper using of the drilling machine. For the physical hazard, it has the same OSH regulation as the first process. The preventive measure is proper handling of material and lighted workplace to be able to see if the wires are shorted. The second hazard, it is classified as a chemical hazard. OSH regulations are physical agent, general ventilation, respiratory protection, and it is needed to have a face mask to filter the inhaled air. For the risk of getting cut, it has the same hazard classification. OSH regulation is preventive measures of the third process. For the fifth process, screwing the boom to the platform, the hazard is risk of slipping due to the improper handling of bolts. It's classified as safety hazard. OSH regulation is PPE and illumination. It is needed to use necessary provision like helmet, gloves, and safety shoes. For the cutting the aluminum elements, hazard the classification, OSH regulation, and preventive measures is the same with the third process. For the drilling slots in the boom for the elements, it has the same hazard classification, OSH regulation, and preventive measures as of the cutting the aluminum elements. For the drilling of slots in the boom for the elements, it has the same hazard as the drilling the aluminum boom is the risk of inhaling metal fumes, and it has the same OSH regulations. It is needed to have use of facial mask to filter the inhaled air. Lastly, screwing the aluminum elements to the boom, it is the same it has the same hazard classification, OSH regulation, and preventive measures of cutting the aluminum elements.
This is Margret and this is the continuation of the PFD process of dipole antennas. So the next step will be the screwing of the terminal connector block to the boom. And we have the risk of getting caught, and its classification falls under safety. We have to prevent by using PPE and using proper illuminations, therefore it falls under its OSH regulations. This is an example of screwing the terminal connector block to the boom. The next step is the sheeting of the coaxial cable. We still have the risk of getting cut, however it differs from the OSH regulations since we will have a hand-arm protection and welding or cutting. So in order to avoid this, we have to use gloves. The next step will be connecting the coaxial cable to the terminal block. Now we have the risk of getting electrocuted, and it falls under physical. And its OSH regulations includes electrical installation, PPE, and electrical safety inspection. Its preventive measures include proper handling of materials and lighted workplace to be able to see if wires are shorted. This is an example of the coaxial cable, and we can see the person is using their bare hands, and it's very vulnerable to cuts. The next step will be the sealing of the connection of coaxial cable and terminal block. It has the risk of getting burned from soldering the cables and terminal blocks, and it falls under the physical classification. We have to prevent it and use gloves in order to protect oneself from being burned, and we have an OSH regulation of PPEs, hand-arm protection, electrical installation, and electrical safety inspection and illumination. We can see here the connection of coaxial cable and the terminal block. The next step will be the testing of the finished antenna. We have to use the proper equipment since we also have the risk of getting electrocuted, and it falls under safety and physical. It has the same the OSH regulations. This is an example of a finished antenna, and we can see that the person can be very vulnerable to electrocution. The next step will be the putting of zip ties. We have the risk of getting cut since zip ties can be very sharp at the end. We still have welding or cutting, PPEs, illumination, hand-arm protection. Of course, we have to use proper protective equipment or gloves. We also have to print user manuals and specifications, and it still has hazards of using a defective material and being electrocuted if not inspected surely. We have OSH regulations of electrical installation, PPEs, electrical safety inspection. And we have to use working materials to not be vulnerable to hazards. The next step will be the boxing of the product, and we have the risk of getting backache, and its classification falls under safety, and its OSH regulations falls under general provisions. We have to properly handle the materials, as well as the next step of wrapping the box with bubble wrap. we still have to carry it with our legs, not our back. And this is the end of our discussion.